Hi, so in this first segment I'd like to tackle two key ideas. The first is what is the design problem, and the second is how do we go about solving it. So in this first section we ask what is the design problem and how do we solve it. So this will take us into modelling, this will take us into abstraction, and this will take us into thinking about exactly what makes up a good design and what makes up a bad design. Let's find out what we're dealing with. What is a design? It's a plan or a drawing to show the function and structure of some building, garment or other object. Or at least that's what the Oxford Dictionary tells us. For software, we actually need to think a bit more carefully about what it is that we're dealing with. For example, what exactly is the object? For software, what is the object? It's certainly not concrete. It's certainly not tangible. It's in many ways abstract. If I was to drop 3 megabytes of software on your foot, you probably wouldn't limp, unless it was stored in a very, very large hard disk. And this is the nature of our reality. It's abstract. It's not tangible. We have to think about it in different ways to the ways that we think about other engineering things. It's also logical. It executes. It runs. It delivers results in a stepwise manner. It executes according to a certain set of rules. So this really influences the design of our types of objects. And the plans and the drawings that we use in software engineering really tell us more about this abstract logical reality than they do about physical things. When I think about a design problem, I think about 3 different elements that have got to come together to create the final piece of software. There's the structure, its behavior, and the way that the different elements have got to interact in order to bring about the objectives and the goals of the software system that we're talking about. So when I think of structure, I normally think about the entities and the relationships between them. So in software, what can the entities be? Well, these are things like functions, methods, classes, modules, and all of the other ways that we can partition a program or a set of programs into smaller pieces. The behavior is the way that these entities execute on a machine. And this behavior can change. If we execute the same program on 2 different machines, we might find that it runs faster on one machine, slower on another. We might find that the way that it raises exceptions on one machine is different to the way that it raises exceptions on another machine. And also when I think about behavior, I think about responses to events. If we move the mouse, what is the system supposed to do? Is it supposed to highlight something? Is it supposed to change the cursor position? How is it supposed to respond? So these things to me are behavior. And finally, interaction brings structure and behavior together. Interaction is about how the pieces, the classes, the functions, the modules, interact with each other to solve the overall problem. It can be protocol on a network, or it can be a sequence of message calls in an object-oriented system. So in our work in this subject at least, we're going to focus very heavily on the structure, the behavior, and the interaction that occurs within designs. So, what exactly is the design problem? Typically, we start with a set of requirements. These are needs, functions, and constraints given to us from outside. They come from the client, they come from stakeholders, they come from people who want something done. As designers, what we have to do is we have to deliver something that functions on a machine. a tangible piece of software that meets those needs, those functions, and those constraints. The problem for us is, how do we get from the needs to the solution?